Okay, thanks a lot. So in this presentation, I will give you a status update on the build and deploy bot, should it be in the future. And the bot, so the goal of the bot is to automate how we build the software layer, and then also how to deploy it. And what is depicted here is the current status. So there are some scripts used there. They are mostly coming, I think, from the software layer repository, and some steps are automated once you have uploaded the tarball to the S3 bucket, but a lot on this left-hand side is not updated, is not automated. And in the future, I don't have to say much about this because Kenneth has shown this morning. So what we want is that this whole procedure is automated as much as possible, but with human oversight. So there could be someone wanting to add a piece of software. The first thing would be that someone is reviewing that pull request, and then the bot should start building for different architectures and so on. And then there could be some testing, and also testing could be later on. So all these green marks here is not that this is already existing. It's just sort of someone says this is okay, and the procedure should go on. Yeah, or maybe the reframe testing is okay, and we can go on. So what is the current status? So there was some work in the hackathons in December last year and January this year. There's a link to the repo if you want to look what has been done there. Kenneth has developed a library for handling GitHub events. That was in March this year. So the current implementation of the bot is based on this. So it just takes care of handling basic stuff when you receive an event, validate the event, and things like that. And also then handing over the event to defined functions in your bot. And all that was a good basis, I would say, for resuming work in May. And then we have developed the bot, how we have it at the moment, and soon see how it looks like. So most of the work has been done on the EasyBot software layer repository. There was also some work necessary, some adjustments necessary on the software layer repository itself, on some scripts, but we try to keep those as minimal as possible. And we have a large pull request on 24 in this repository. This is flagged as work in progress. What the bot can do at the moment is it can receive events, it can submit jobs to a Slurm cluster, it can monitor the jobs and update the pull request for software to be added with comments. The bot can also be configured to work in various environments, and I can tell you more about this in a moment. Okay, so this slide is a bit complicated. It tries to depict how the bot works. So what you have is let's say, an easy software layer repository or a fork of it. You need a GitHub app. You need a SME.io channel for relaying events. You need on the cluster frontend where you want to run a bot instance, you need a SME client. And the bot is actually two components, event handler and job manager. And then, of course, you also need a shared file system on the cluster, scheduler, and some compute nodes. And so this cloud here should not depict the cloud, but the internet where you see some software packages and things like that. Yeah? And I hope if the animation works, then you should see how this works in general. So first thing you have to do is you have to register a GitHub app. And install it, that means that you associate it with the repository. Once that is done, and what you also need to do is when you run the SME client, you have to point it to some channel on the SME.io service. So that's what you have to do in the beginning, and then when there's a pull request on the software layer, the event events the app has subscribed to relate to the SME channel, and then via this channel to your SME client. Yeah, and then the SME client forwards this to your event handler. And then the event handler, so the event handler can get any kind of events, not only on pull requests, but let's say maybe we focus on pull requests for a moment. And when the event handler receives that event, then it prepares a job and creates a directory for a job, and it gets the pull request from the repository and applies a pad to it, and then submits a job. And what at the moment it is done so that it submits the job in user health state. Yeah, so the job is in the queue, but it's not run automatically. And what it's also doing is it updates the pull request with a comment saying like, okay, the job ID is that, and this is a job on this system. The job it's running for specific architecture, and when this is happened. And then the other component, the job manager, comes place. It checks basically the shared file system for known jobs, and it also checks the queue, and it compares this. So then it uses both sources to detect new jobs, but also finished jobs. And when it detects the new job, it releases those jobs. So yes, it runs as control with the job ID, and then the job is released, and then the scheduler can, when the resources become available, start the job. It also updates then the pull request with a new comment saying, okay, the job is now released. And then the scheduler at some point will start the job, and post the job, those work on the shared file system, and they fetch data from the internet, like installing EasyBolt sources and so on. Yeah. And once the job has finished, then also the job manager detects this, and it updates the pull request with another comment. So that's the basic steps. I think I don't think I have gotten anything. So everything what you see in this on the right hand side, this is now running on 6 systems. So Betsy, it's a Zen 2 system. Norway, France also it's the Broadwell system. It's also Norway. Saga has Sky Lake and Pacific Lake, and also Norway. Fox Zen 2 is also Norway. Sorry, but an interesting system. Has AMD processors, Intel processors, ARM processors, and also in Norway, and it also runs on the AWS cluster. There's also a lot of different architectures. Yeah. And to make it even more interesting, so for development purpose, we have made a self-host repository called pilot.nessie.urlcloud.no. So every component like column 0, column 1, a client build node runs on the NREC that maybe Terry has also mentioned, that we also run a public column 1 server for Easy. And it can build, the bot can build both for the Pilot Easy repository, but also for the Pilot Nessie repository. Yes, so that's all for how the bot works. So now I have some random thoughts.
Thomas,
yes, yeah.
Can you hear me? Okay, before you
Yep.
let me walk in view as well. Before you do the random thoughts, can you give an example of a pull request where the bot was reacting to, so we see what those comments look like? I think that's interesting as well.
Maybe I do it later on. Yeah, then I can just switch
okay.
to my web browser. Yeah,
yep.
Then no problem. So I think this. So I started with this in May. It was a lot of fun, but also of course a lot of work. Some frustration, of course, but mostly I would say it was fun. So more serious thoughts. So I think this whole thing needs much more testing, usually from non-developers. So not just me. Possibly we could also think of automating some of the testing to detect regression. Yeah, so something. So there are many moving pieces, easy build and the software layer and all these things, and then firmware and so on and so on. And any change in any of those components can make it happen that something doesn't work anymore, not completely. And it would be good to have a good overview of when things start failing. I personally, because maybe because I don't have so much experience with GitHub and procedures, it would be good to have some well-defined GitHub setup for this. So what I have at the moment is I have a fork of the software layer repository, and then I have a fork of that fork because just to simulate how I would have a fork of the easy repository and then make pull requests to the easy repository. So at the moment, because I don't want during the development make pull requests to the easy software layer repository, I make basically pull requests to my first fork. And things like, and there are of course many things that can go wrong if you don't do it in the right way. Yeah, but yeah. I think unit testing is maybe also something we should think of. I think in the beginning, when we started this in May, we said that we should do test-driven development, but yeah, we didn't do that. Yeah. So it's still a lot of fun. Okay, so working with a distributed setup, I think it would be great to have much improved debugging logging capabilities. If you run disconnected here, I don't. Okay, sorry. If you cannot hear me, just let me know. So if you do the installation of the software, if you run this easy pilot infra software script yourself manually, then and something fails, then you can easily go in and check all the logs, and so that's relatively easy, I would say. Yeah. But if some job somewhere is doing that, then it would be nice to have better levels of logging, maybe component-based logging, so that you can investigate much better what goes wrong. I think it would be good to have better understanding of the whole tool environment. So at the moment, the bot uses some Python packages, and sometimes it felt like there were some events queued, but I don't know why, and I don't know how to influence this. So things like that, or maybe at the moment, how the installation script works for the software layer, it checks if EasyBuild is available in the software stack that is based on, and if not, then it starts installing it first with pip, then it installs the latest release, and then installs the required release. And at the moment, this doesn't work for me, where I tested this on a new architecture. And so then it's interesting to understand why it doesn't work and then what is expected and what goes wrong. Is that something I can change, or maybe someone else has So as I've shown, I have set up the bot on several instances, and there's some work to be done setting it up, and maybe it could be possible to also automate this. Yeah, sort of have some self-config procedure for the bot. And I actually have some script to help me a bit with finding all the necessary information, or most of the information, but maybe that could, I don't know if that can be automated fully, maybe not, but maybe it can be assisted. Yeah, so at the moment, as we have shown Kenneth earlier today, and also me in the first slide, we have some goal procedure for building software and deploying it. Maybe we could think of having this also configurable, like in the workflow. But that's just some maybe weird idea. So then maybe when I show you how this looks like in a pull request, you will see the many comments to such a pull request. So that it could be quite overwhelming. So I was thinking that maybe it could be interesting to have something like a control center. So at the beginning of a pull request, you just have a table which gives you an overview of what's going on, what's the status of different instances of the bot, what they're doing, and so on. And maybe you could, via this, you could have a button to redo a specific build job, or to switch on and off bot instance. Maybe if you want to work on this one pull request and it fails only for one instance, for one architecture, and you want to redo this, maybe it's interesting to just switch off all the other instances. And of course, you can do this on all the instances where they're installed, but it could be nice to have do this in the pull. And then it could be interesting to know what are the available compute resources for building, knowing the costs of the building, like what was the history for this spot. Maybe you could estimate what it would mean, and maybe if you know this, it would be too costly on this spot. And you have another one for the same architecture, you switch this one bot instance off, and so on. So there are many ideas to do. Yeah, sometimes I mean, it's okay to if you want to change something because something doesn't work in a pull request, you want to adjust something, maybe add some debugging information or so. It could be interesting if you have a means that you can just rerun that job on that architecture and inspect locally what's going on, why it failed, without updating the pull request and then starting the whole procedure. That could be an interesting maybe tool to help you. Yeah, so there are some other ideas. Parallelization is maybe an interesting idea. So you could, of course, take benefit of having multiple cores in a single node. So that inside a job. Of course, then you would need to ensure that you actually make use of all the cores there you ask for, and not wasting them. For a pull request, you could think of splitting a build job up into several. I think maybe sometime today or so it was also already mentioned something like a coordination of multiple concurrent build jobs. So if you have many asking for packages to add, how to coordinate this, so that they don't override maybe partially as a result of each other. So I think for the building itself, it's no big problem, but for the deployment, I think that's maybe interesting. The access control is also an interesting area. Who can trigger the bot actions? So at the moment, the bot is not starting to work when you open a pull request on the software layer. It only starts when you add a label, bot :build. And it's planned that if you add a label bot :deploy, it would then deploy what has been built before. So who can do this and how to control this? Error handling, maybe no wonder, I don't know, but at the moment the bot is doing almost no error handling. Yeah, so many things that can go wrong, and sometimes the bot just crashes. Sometimes the bot is building something else, not what you wanted, yeah, or maybe not the version you wanted. So that's something it can be quite annoying. But okay, that's work in progress. The bot or bot instance, they could have some alive check. That could be something for this control center I mentioned earlier. It could have an overview of the resources, consumption, availability, maybe the health information of the bot. I don't know what it could be. Maybe you could also send a probe to bot. Say, okay, how are you? Yeah. It could respond what it can be built on a certain instance, and so on. Yeah, some more general ideas. I think maybe we would want to have a better design for the bot, maybe redesign and just see the current implementation as a first attempt. Okay, so that's all the random ideas. So I think if we look at what the current status is with the pull request I mentioned earlier on the EasyBot software layer repository, so if that would be merged there, then we would be one step closer to taking the current version. Yeah, I don't want to say into production, but into use, and to actually use it for building a software stack. Yes. So then the next step would be to implement this deploy phase. There are some ideas. Possibly that the step is easier than what has been done before. Yeah, and then I said start using the bot build software for the next easy pilot version. We could use, for example, cluster on LTRS or any other cluster that set up. Yeah, and there were some discussions about what architectures to support. From my point of view, I would probably not limit this. So if we have an architecture and the resources available, why not building it? So my experience from doing the installation on several different systems is you learn something from these systems, and as long as it is only pilot version, and we don't have to invest too much manual work into maintaining the installation, maybe not to limit this. And then I put parentheses around this open the door start exception community contributions. I would probably say that the bot is not ready for this. So I would like to see many improvements. Okay, so just a standard slide for this, and now let me see if I can. I probably have to stop sharing first. Out.
Yeah, while you're switching to that, are there any comments or questions here in the room? Or remote? Yeah.
So is there any possibility of this bot being abused to build something else or to run something else?
Sure. That answer I can certainly say yes. So, but if you ask a more specific question, then I could say maybe yes or no, or maybe no.
So that means that people who have access to the repo can actually do this, but at least you know who did it, correct?
Yes, I think so. Because what you see in the event, you see who sent the pull request, and you see also At the moment, what is interesting is who set this, for example, this bot colon build label, and I think you can see this. Probably one thing we have to implement very quickly is to filter who can set this, or let's say maybe not who can set this, but because I think that's not possible to restrict it. At least I was not able to do this on my own repository. But then the bot only starts building when certain people or accounts have set this label. See how okay.
I helped a bit with Thomas on the design of the bot, the overall design, and one of the things or Thomas tried to do in his implementation is to keep the bot as stupid as possible, in the sense that for the building it's basically running a build script, and it doesn't care what's actually going on in there, whether it's building for easy or whether it's using easy build or whatever, it doesn't matter. And the idea is that the bot has different phases. For now, it's only build. To really be functional, we need build and deploy. What deploy means, the bot doesn't care. It just runs a script. For test, same thing, basically. It also doesn't care. And you're basically feeding in the relevant information of the event data, so which pull request, maybe that's enough, into the build script. And then the build script does something with that to figure out what it needs to build. And the bot really doesn't care. It's just feeding data to scripts and right order. And yeah. So it's dumb as a doornail, and that's good. Yeah, maybe you can.
Okay.
Yeah. Thomas, go ahead.
I don't know if you can see this now. So
maybe you zoom it in a bit.
Okay, a bit
more.
Yeah.
Or make it full screen. Yeah, that's good.
Yeah. Okay.
Yeah, that works.
Okay. So this is just an example pull request. I just used one very small soft package. I don't know what this is. And so what I did here is on my second fork, I just from this I made a pull request to my first fork, and then the bot is installed to my ERZ42 repository fork of the software layer repository. So the first thing you see is that you get basically just a normal thing what you would get. I added no description. I could add to this, and then what I did is I added this bot build label, and then you see entries added like this. So and it starts first with EasyBot develop something, and then with this first line job, that's job ID on a system. That's one of the systems in Norway. PR is just an abbreviation for the account it runs on, and then it states for which CPU family it works and builds and the microarchitecture. It has the directory. I can then just easily copy and use when expecting this. And then first it adds a line like this on this date. It submitted the job, and the job waits for release by the job manager. And then shortly after, so the job manager checks every 60 seconds, but we can also configure this for any change on the queue or jobs, and then releases the job, and then what you see here is after a while, with only about 3 minutes, this was already finished, and it's heavy here. Yeah, but later on it's not heavy. I can show you. It basically says, okay, this was successful. A table was created with this name, and okay, so that was probably very small table. It could be that, and maybe not in this case, but sometimes it could be that all the software that you wanted to build with the pull request is already included in the software stack, or maybe that's just very minimal and therefore it's just not. It looks like there's nothing in this build. And then what you see here, there's another system, this X3 system where you want to build for AMD Zen. Okay, and here you see, for example, that this didn't work. So there's one thing where the bot at the moment has a little bit sort of intelligence or needs a bit knowledge of the internal workings, is to analyze the results of such a build job, and that is when it tries to generate these messages. Yeah, but this could also be outsourced to a script, and then the bot would just call the script and spit out this message.
Yeah, so the way that the bot currently checks for the status is essentially implemented in Python code, or?
Yes. So
yeah.
It just checks for a certain message in the Slurm output file.
Yeah.
If all the missing, so there's no missing installation, and if a tarball has been created, basically. So that's and you see, okay, so there's another system for the same build, basically, but here it's built for generic. And it's successful, and then here it's built on the AWS cluster for Haswell, and here again with this X3 system, here it's built for Zen 3, so you can have basically one instance on each system running, and it can build for different architectures. So for every architecture, it then submits a separate job. Okay, and there's another system building for Zen 2, another system building for Cascade Lake, the same system building for Skylake.
Yeah, so we're
same system also building for the generic. So if you have 10 different architectures in one cluster, you can build have 10 different jobs in the same system. Yeah? And you could also have 10 different systems, each building only for one. Yeah, also you could have maybe 2 systems building for the same architecture, just to have, you can compare them, maybe the builds if you want to. So there are a lot of possibilities. Okay, so
and well, right now the bot is basically assuming it's running on top of Slurm. That's definitely good enough as a first iteration, but eventually we want something like a bot that just runs on one build node, doesn't need Slurm at all, doesn't submit jobs at all, but maybe runs script in the background or something like this.
Yeah, so the bot at the moment just needs some Slurm cluster environment, where it can submit jobs, and it needs a shared file system now. So
but Kenneth, you're saying you don't want the bot to be aware of? I mean, eventually, yeah. So probably you should separate it, right? Because you still need some, like, if you want to build on a cluster, you still need some kind of intelligence to manage the checking of the etc. And then what runs on the node could be a different. Yeah. Okay. Yeah. Fair enough.
So I think what we could have in the future is just to have something that just creates some build job, but build job is maybe not really a Slurm job or a job on a cluster, but could also be just a process that is running in a certain directory. And then you need another function which is able to detect the progress of the job, or the progress that the job has ended.
So you're intentionally trying to be Slurm agnostic. Expressions GitHub seems ironic.
I don't know. Well, sorry, I didn't understand what you said.
essentially it would be pretty similar to what Reframe does. For Reframe, you have the option to talk to a scheduler. You also have the option to run locally.
Yeah, exactly. So we would probably have some some abstract class interface where you just create jobs or something like that. You monitor them, things like that. And then you can, based on what you have on the system, you can configure it such that you submit a Slurm or something else, or just create processes.
Hi, Thomas. Amazingly enough, I've seen you picture all over the place. Nice to say hi. Did I hear that there's a requirement then of a shared file system as well, in order to get stuff to presumably migrate itself back to the scheduler location? Is that what?
Yeah, at the moment you need this because I think on the cluster on AWS, so there's no way to know the status of jobs when they have ended. Yeah, so you need to store information about jobs that you think that they have submitted, that they have existed. Yeah, and the only way, at least I thought it maybe, is to make this
I think maybe I missed.
after a crash or so, is that you have stored on the file system. And if you prepare, if the bot event handler, if it prepares the job environment, it has to store somewhere, and the job then runs on some compute node, so then they should have access to the same file system. Maybe you could also do this differently and say, okay, this you just submitted a job, and then the job just needs access to the internet from that compute node and does everything themselves. So you can also do it like this. So, but then you just
I'm wondering about the entanglement build and deploy phase. If you had the ability to deploy from the themselves, then you would file system. But that and an entanglement that is actually desired.
Yeah.
So that could be a problem.
Yeah. So I think there are different ways to go forward. If you, at the end of the build job, if you have made a tarball and if you deposit it somewhere, from where then maybe the bot can have access to it, then you don't need the shared file system. But so at the moment, it just sort of simply, it makes life for the development easier, I would say. But in the future, we could also think of other ways.
I suppose technically speaking, depositing a tarball somewhere is a different kind of share. Perhaps not a traditional one, but anyway.
Yeah, and usually if you have a Slurm cluster file system, there's no point in having a Slurm cluster if it doesn't have to that doesn't have to be very, very performant or anything. You just need a place to dump a couple of megabytes. Well, prepare the job directory, then the job can start in there, and then the job prepares a tarball that has to come back to the bot essentially, so we can then kick off the deploy. And so and the shared file system just makes that way more easier. And in general, if you have a Slurm cluster, in most situations, 6 systems. And if you local modes, well, local disk. So to start with, that's more than well enough. And if we want to do, SSHFS is an option. And actually, for the Slurm versus local mode thing, we're now talking directly to Slurm. There's libraries out there that you can talk to that for you, and you can configure. So if we look at something like this, we can actually get rid of the Slurm and maybe support other schedulers for free almost. Yeah, you just but so libraries like this already exist, so might as well.
Yeah, but I mean, okay, so I had access to 6 clusters. Maybe I could have access to 10, but at all the clusters they have. So
so that's
and
a
of
pretty.
course, as you say, if we get access to a fancy new machine with a fancy new architecture, then we have no means to run jobs on this locally, maybe we just install Slurm. Yeah, so it's, I don't know if that's really a difficult thing to do.
For now, sticking to Slurm is good enough. We'll have other issues to fix first. Okay. Questions? I think I had another one, but I forgot what it was. Not the local thing. It was something. Oh yeah, I guess the test-driven development stuff. So we didn't do that because in some sense it holds you back a bit. But maybe now you have learned the hard way that if we would have done that from the beginning, it would have actually helped you by now. Is that fair or?
I don't know. I think you have to be able to define tests.
Yeah. But that's something I think I can help with quite a bit because I'm very keen on testing and I'm not afraid to mock out a lot of things and write my own S-batch that actually not really talks to Slurm at all, but just acts like it was and it gives you a 1, 2, 3 job number and just does something like this and just to see how the bot reacts to things happening that you expect. That's the first thing, and then the next thing is what if something happens that you don't expect? How does it react to that? And then if you have tests like this and you rewrite half the code, like we talked about redesigning and coming up with a better design based on the experience we have now, if you then have a bunch of tests that you can run against, that's a big help. You want to refactor everything. So I'm not saying drop everything and do that first, but that's probably a helpful thing to focus some time on it. But yeah, the first step is definitely getting the pull request merge that we have now. And then hopefully getting some extra helping hands, like open issues for all the ideas we have, prioritize them. The deploy phase is probably a big one, and you can see how it